Ladies and gentlemen, let's talk about the sum and the difference of cubes. Now, we have done things like a squared minus b squared, so we have squares. And in that case, we said, oh, that was a plus b, a minus b, because when I multiplied it out, we had a squared plus ab minus b squared, and the two middle terms crossed out. If we had a squared plus b squared, in fact, that was problematic because the only way we would ever get this is with imaginary terms, because if I have a plus b and a plus b, a squared plus ab plus b squared, we're going to end up with a squared plus 2ab plus b squared, and you get this middle term, and it's kind of a mess. So it was nice when it was squares with a minus. It was not nice squares with a plus. And you certainly can't just assume that it's going to work when we go cube, because when we go cube, this whole two-part deal where you have one positive, one negative does not happen. Now, there's a whole way to actually derive this and prove this, but you don't care. Trust me. What you need to do is memorize that a cubed plus b cubed is a plus b times a squared minus ab plus b squared. So this turns into this format. A cubed minus b cubed is a minus b, a squared plus ab plus b squared, this format. The kicker is the a plus b is exactly matching of what it is here without the cubes. And if this is plus, this has to be minus. On the other hand, if this is minus, it's the same to start with without the cubes, but it's the opposite sign in the middle here. Now, let's put this into action. If I have x cubed plus 8, you say, well, that's not cubes. Well, yeah, it is, because x cubed, and what is 8? 2 times 2 times 2, 2 cubed, which means instead of a, I have x, and instead of b, I have 2. So if I have a situation where I have x cubed plus 2 cubed, that's going to be this situation. Well, x plus 2, because it's the same, x squared, now if that's plus, this is minus 2x, plus 4 at the end, and there it is. So all I have to do is use this to transform or translate it into a factored form. Now let's do something more challenging than that. Let's go 27a cubed minus, let's see here. I don't know, let's go with 8b cubed again, and let's make a c to the 6th. There we go. So in this case, this is still a perfect cube because I could say 3a, the whole thing cubed, would make 27a cubed. This is still a perfect cube because I have 2 and a b, c squared, all to the cubed power, so to the third power. Now let's see if that works. 2 cubed 8, b cubed, c to the 6th. Yeah, it works out. So let's put it into our format. So it's going to be something minus something, parentheses, something squared. Since that's minus, this is plus something times something, plus something squared again. With that in mind, what goes in here? Well, 3a is the cube root, 2bc squared. So then I'm going to get 3a, and don't forget, we'll square that in a minute, plus 2bc squared times 3a with a 2bc squared squared. Now, over here, nothing really changes. So that works. This we could simplify to 9a squared. This we could say, oh, 2 and 3 make 6. Then I got an a and a b and a c squared plus, now what is this thing squared? Well, 2bc squared times 2bc squared is 4b squared c to the 4th. And so that's breaking it up. That is sum and difference of cubes. It's not particularly challenging provided you know that format. If you know the format, easy. If you refuse to remember the format, it's impossible. It's as simple as that.